Now in this video we're going to come back to the circuit of the last video. There's 4 NAND, so not AND, logic gates in that integrated circuit. We need both inputs to be high for the output to be low. There you can see if I go low on one or the other, right there, or both of them, then the output is high. That's not the main thing we're interested in this video. Here you can see we got 11 milliamps of current needed when the output is high, and about 2 milliamps of current when the output is low. As we see there, right here it is floating, so it's bouncing back and forth, so the amount of current is going to be about halfway. But in case we got about 2 milliamps of current there. So last video I didn't film it or anything, or at least I didn't show any of the footage I filmed, but we have the inputs tied to the supply rails. I accidentally took the supply rails there and put that one to the output of that NAND gate, and this one above it, right above that. And so it was wired like this. Don't do this, but if you accidentally do, hopefully the integrated circuit is not damaged now. When we zoom back though, watch right here and how much current we are getting there. I'm going to set one of the inputs low so that the output goes high right there. You can see we hit 20 milliamps of current and we got the constant current there. So normally when I have LED circuits, unless I need more current, I limit current to 20 milliamps to help protect them from burning out. And hopefully that's one reason why this integrated circuit didn't burn out. More interesting than that though was the oscilloscope. This is actually where I first noticed this. So we got about 4.5 volts at the output right there. I have the red alligator clip of the oscilloscope clipped to that jumper, and then the black went to ground. So that's 5 volts above ground. You can already see we got some problems right there. We're gonna set the output low. It went right to 0 volts really nicely right there. What's going to be a lot more interesting is when we set the output high. There you can see it keeps kind of oscillating its way up until it gets to that final voltage. And here is a closer look of that right there. You can see it going up. So I don't know if that's protection circuitry. Something's getting hot and it's limiting current somewhere else or whatnot. So finally we can get the full voltage at the output. But in any case, if you look at the schematics of the integrated circuit and understand transistors well and whatnot, you may figure out what they did. Maybe that is protection circuitry. But now that we looked at it when it was wired wrong, I corrected it again. You can see we got supply rails and input, output for all these right there. So output down at the bottom, output at the bottom. Now it's clear. It is floating the way it's supposed to be, but the inputs have a voltage to them. And we got 0 volts there because the power supply is off. There we go. And still the output 0 volts. Both of them are high. Now I got one of them low. You can see it jumps right to 4.5 volts right there, and maybe a slight delay there. But in any case, it jumped pretty nicely and it's holding pretty nicely. Maybe it's not as good as it should have been either, because maybe we damaged it a little bit. I don't know, but it was definitely worth risking damaging it again to make a video. Unfortunately, I bought 2 kits that have these and I fried the other one. So I'm using my backup one. And I was really worried when I made the last video that I had just fried all of them. So I think I may have some more. This is a common integrated circuit. May have some more in other kits. They come in a lot of kits. These NAND ones, the 74HC00. So in any case, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen. And check out the links down below. They all help out a lot. I'll see you in the next video.